All right, I think the stream is live. Now I need to get the chat working. How do we refresh this? All right, I think the chat works. Hey, that was quick. Still getting my chat configured. I always have to do this because otherwise you never know if it works. Welcome back. You must have notifications on. All right, is everything working? I think so. My internet just went out, so I'm kind of paranoid that this might not work too long, but we'll see. So I made good progress since last time, actually. I did some good work the last couple days, because I've been working on metal, if you remember. Favorite, that's a tall order. This is, yeah, okay. So last time on the stream I was working on metal, and I got to the point where the screen was a red screen. Well, I've gotten past that now, so I can actually see the game now. So this is running metal. Only one, exactly. This is actually a lot of work to get to this point, but also not too much. But I have to continue this today because there's some stuff I still have to do. So I'm gonna do that. So there's some problems where, so I can't resize the view. See, it just like squishes everything, which is kind of fun, but not quite the right behavior. So I need to fix that. And also I don't think the other projects actually work. Like this one, I think this one just fails catastrophically. But I have to change some stuff first. So I think this one just doesn't work at all. Yeah, we have reached the 90s. All right, so what does this not like? It doesn't like. Interesting. So it doesn't like the render targets, which actually isn't what I thought would be failing. So that's interesting. Maybe I can fix this pretty easily. Let me see what the problem is. I'm still working through my remote desktop, so this is kind of an awful experience, to be honest. Maybe I can make this a bit bigger too. For us unks. Sometimes I'm starting to feel like I've reached unk status. It's an odd feeling. All right, let's see. What was this mad about precisely? So it didn't like line 1090, which is this one. Oh, it doesn't like resolving the MSAA. So what if I just turn this off? No, okay. Segfault without an error this time. Yeah, I feel like unk status nowadays because my birth year starts with a 1. It's like, wow. Everyone's so young these days. Okay, so let's see. 2852. Didn't like that. 2852. That's the same function. Render fast begin. Bind targets. So what could be wrong? All right, I'll fix this at a later time because I'm not going to be able to fix that right now. Let's see, do the other projects work? Like, I don't have the chest one on here. Let me make sure this one's actually up to date as well. Okay, this one actually does work. Just make sure it's up to date. Hey, there we go. The chest demo does work. Kind of. So it's not working fully. Yeah, the mouse is all messed up. Or that the mouse is fine, it's the screen that's messed up. I think it's just the viewport though. If I, oops, what just happened? All right, so it's a bit busted. I'll fix these things in a little bit though. I need to do some cleanup, and I'm gonna do this off the Mac because the Mac is hard to work on. So in my foray of implementing metal support, I realized some issues I had with how I was doing buffers. Oh yeah. Yeah, it's because this stuff over here I think you're looking at, I'm just printing some debug stuff for every time a frame. I was just about to start explaining this actually. So I don't know how deeply you know graphics programming or OpenGL or DirectX 11. And honestly, I don't know how deeply anyone knows this stuff unless you like spend all day thinking about it. But so I only had support for OpenGL and DirectX 11 so far. And basically, well, where do I even start with explaining the problem? Let's just go to it. So like, let's go to a draw call. Yeah. So basically, you can think of the graphics card and the CPU as like two separate computers pretty much. And they have to communicate with each other because they're both doing work, right? The CPU kind of like is the brain, and the GPU, you know, does like the brute work of rasterizing pixels, right? Like that's obvious. That's like what the two roles are. And the graphics APIs, they're all just different ways of representing the same ideas for like how data transfer happens between the CPU and the GPU, and sometimes back to from GPU back to CPU. But ultimately, like DirectX, OpenGL, and Metal, they're just different ways of describing the same fundamental operations. So when I was designing my renderer, I kind of like, you take a step back and you think, okay, what are like the actual abstractions? Like what are the actual fundamental things you need to do in order to render? And pretty much the two main things are you have buffers and you have I guess, well, there's a couple main things. You have buffers, you have textures, and then you have like render state, which is like, you know, what is the blend mode? What are the raster modes? So like, do you have culling enabled? Do you have depth testing enabled? All that stuff, right? So you have like 3 kind of things you keep track of. And then each of those obviously branches out a bit more into like specific things it does. So like buffers is a broad thing. You have a buffer, but in the subset or under the umbrella of buffers, you have like vertex buffers. You have like constant buffers for data, which is like shader uniforms or like other data that you'd want to be able to access in either like a vertex shader, a fragment shader, or a compute shader. And long story short, the DirectX 11 and OpenGL drivers do a lot of work for you in terms of managing how those buffers actually are, I guess, created and synchronized between the CPU and the GPU. And Metal does not do that for you. You just have like a raw interface that lets you like create a buffer, and then it's kind of up to you to actually like use the buffers in a safe way. That's like a really high level overview of the problem. So I had to like, I guess a big example of where this is a problem is that, say you have a vertex buffer containing like all the vertices you want to draw in a single frame. And then say each frame you generate that buffer, right? So like each frame has unique stuff you're drawing to the screen. When you're in OpenGL and DirectX 11, you just ask the API, ask DirectX for a buffer, and then each frame you can just write to it, and then draw it through a draw call. And under the hood, DirectX is actually doing a lot of stuff that I guess you don't think about, because it turns out that frames don't actually execute in, you know, a predictable timing. So like you might have multiple frames in flight on the graphics card, so the CPU and the GPU aren't actually like in lockstep with each other about which frame is being like worked on the CPU and which frame is actually being, you know, executed on the GPU at any given time. So like, here we go. Here's the DirectX. I'm just kind of like talking as I'm looking at my code. And I'm talking a lot because I'm going to have to come up with a way of solving this. But in DirectX here, we create a buffer. So this is like a buffer description, and you give it some stuff. You tell it, how are you going to use this thing? How are you going to write to it? And I guess this is like a binding thing. It's just like, what kind of buffer is it? So like in DirectX, you can just tell it, hey, this is a dynamic buffer, which is basically something that you intend to mutate a lot between frames or even within the same frame. And the driver is going to like take this hint as a way of knowing how to actually like allocate memory for that thing under the hood, and like how to give you access to a buffer in a way that won't kill your performance. So internally, what a usage dynamic buffer does is it creates not just one buffer, but a pool of buffers. And it will give you just any one of those buffers at any given time, so that like you always have a buffer that's safe to write to, no matter what the graphics card's doing. So yeah, it just gets complicated. And I basically realized that I had to implement that myself for Metal. And I know you have to do this for DirectX 12, and no, it's fine. I'm just kind of rambling a little bit. I was just really annoyed. Actually, yesterday I was working on this, that I discovered this. Or I guess I didn't discover it. I knew this was happening. I just didn't really feel like working on it until now. So what that means in concrete terms is I have to do some stuff right now to actually anticipate this now, because I'll need to deal with this with Vulkan as well. And it's even more annoying with Vulkan because Vulkan's lower level than Metal. So I have this API vertex buffer in it. See, here's like my, what we're looking at right now. This is like my API forward-facing, like user-facing interface for like creating a vertex buffer. So I just have this little class called a vertex buffer, and you can like initialize it, you free it, you can get its current point, like its current write position, you can write to it. Simple. And then this API underscore thing in core GFX, these are like the bridges between my front end buffer and like each graphics API. So it's up to each graphics API to implement these functions. So this API vertex buffer in it, if I just search this, you can see on the left side, I have like my graphics.d3d11. So this is my DirectX 11 implementation of initializing a dynamic buffer. And like Metal, it's done this way. Well, actually, this is not a good example because I'm going to be changing this code. In OpenGL, it's done with this code through like GL gen buffers, GL gen vertex arrays. So yeah, I realize I have this init static thing and this init dynamic, and I've never done this right. And I'm realizing now that this is kind of a stupid thing I was doing, thinking that these are two separate concepts. So I'm going to delete this right now and just never worry about that. Actually, let's do this. Let's delete all occurrences of this in the engine because we don't like this. Yeah, so basically, yeah. If an end user is actually using the engine to make a game, the goal is that they don't have to think about Metal or DirectX or OpenGL at all. Like, they should only ever have to use my little abstraction layer here, this class. And then it's up to like the engine, of course, like the internals of the engine to take this thing and actually, you know, translate it to the underlying graphics API that happens to be running. And the complication comes in that not all of the APIs do the same, have the same exact like. I don't even know how to explain it. They don't do it all in the same way, or maybe they do it all in a similar way, but they like OpenGL does a lot more for you than Vulkan because you're expected to do it yourself with Vulkan. Okay, so init dynamic can just be init. Init dynamic. So we need to delete this. And then, not only this, but now I'm adding some new concepts to the engine. So we just have a buffer now. So we'll have this as a to-do. And then we'll also have, I'm not even sure if this is the exact abstraction I want to do. Yeah, I don't know. It's a tough thing to just plan fully in advance, I think. That's why I respect people who actually work on real products that do this kind of thing. Because like I have the benefit of this just being like a fun project that I'm doing for myself. That like the user is me, right? So like it's kind of just an exercise of, I don't know, software architecture. But there's no, there's no like actual cost to any of the decisions I make because ultimately it's just me who's impacted. And like I can easily just refactor code if it doesn't fit some, I don't know, some future requirement. And that's what I'm doing right now, actually. Okay, so my idea with this is, so I'm going to have a I guess I'm not even sure what I would call this thing. Here, let me go all the way up. So we need to add some new types in here as well. So we have all of our buffers. We'll have just a buffer resource, and we will have a managed buffer, I guess. Yeah, I bet. Yeah, and I guess the thing is, like, if you're a company doing stuff like this, you also have like the pressure of actually needing to create value, right? Like if you're a game company, you actually need to ship games too, because that's how, you know, you pay the bills as an organization. So sometimes you don't have all the time to just twiddle your thumbs and rewrite stuff all the time. So I guess in that respect, it's I don't know, it's nice, I suppose. All right, so how many of these will we have? I have like that many. Let's just say we have, I don't even know, how many is this? This is a lot of resources. And we'll just assume that's fine. Okay, so my idea with this abstraction, so like right here, we have all of these different buffer types, basically. We have like the vertex buffer and instance buffer and index buffer, uniform buffer, constant buffer, mutable buffer. These like last three are kind of concepts of my engine. They don't even, I guess they do roughly map to like graphics concepts, but I've just kind of created these as things I want in my engine. But ultimately, all of these buffer resources are just like derivations of this base buffer thing. And they get more complex, or I guess more specialized, depending on their purpose. So let's see. Just have to copy all of these functions. Managed. See, like we don't need a vertex format. We just have a size and a GFX write mode. I'll even just call this mode because it's obvious what that means. Yeah. Okay, so, and I'm just gonna like write code for a little bit, and then maybe in a little bit, you'll see where I'm going with this. Let's delete. Oops, I didn't mean to do that. Come on. What is the trick to this? You select first and then do this? There we go. Would have been faster to just not do that. Okay. Can single line that, which is nice. Okay, let's see. So now each backend has to implement these, which is annoying. Let's see. See, in DirectX 11 and OpenGL, these won't actually do anything because this is what the driver does for you. So I don't need to use these structures. Return true, I guess. It's only in like DirectX 12, Vulkan, and Metal that these will actually be implemented. So that's kind of fun because I can just stub them in. And then have them not do anything. I mean, I could make them do something, but I don't think I need to. And then I can just copy these. Let's do this one first. Yeah, it is more work. It's a lower level API. So all that means is that the driver does less work for you, but that also gives you more control programmatically. So it has its like ups and downs. Yeah. Okay, so OpenGL needs this as well. And then I should just sanity check that this still compiles. Sweet. Except I have an error. Yeah, I go back and forth on what I think about it, though, to be honest. I think the Metal API is actually pretty nice because I find like it's a decent balance. It actually might be my favorite API that I've worked with yet. It would be better if it wasn't tied to the Apple ecosystem. But I don't know. I go back and forth because I like that they give you control nowadays to like do. It's like the driver's not going to get in the way of, you know, the code that you write. Like it's not going to make assumptions for you. But I do think it can be a bit much sometimes for like what most people actually need a graphics API to do. Like, I think it'd be nice if they gave you the option to use the higher level stuff that was in the old drivers. Like, it just seems a bit crazy to me that I need to implement my own vertex buffer pool with like memory safety, in like, you know, fences, like, like memory barriers. So you're not, I don't know, you're not mutating memory that's already, you have migraines. I don't know. You have to pick a project that you're passionate about. Is really, and that's not even advice. It's just like not good advice because it's hard to just have. But if you're not having fun working on what you're doing, then it's going to be a sad time. As much as I complain about this, I do enjoy working on this stuff because it's satisfying when it actually works. But yeah, a lot of it can be pretty tedious too, so you have to like the process. Okay, does this still compile? Uh-oh, it does not compile. Failed to bind index buffer for index draw. What just happened? Is that real? No, that was a fake error. Okay, and DirectX. I broke the caching on my build system, so it's not it's not dirtying the cache when the files, like the code files, change. So every so often I need to clear the cache, otherwise it doesn't like it. Okay, so that still compiles. Okay, let's see. I don't even know where to start. So I'm working on metal code in both. Actually, let me just commit this. So we have that up to date. Okay, so I guess I can explain how the metal code works, or at least, because I already have partially solved this problem. Because obviously, like I showed, at least in my little metal test project, obviously I have metal working because like the game runs. Oh, I can change these variables too. I made it green just for fun, but I can change the color. This is testing that uniforms worked, and that works pretty well. So it's working, but yeah, so I have all this debug stuff being submitted or printed to the console because yeah, let me think. Basically, you need to, this is basically just telling me that the frame is like each time I write submit here, this is like the start of the frame. Let me go to where this is happening. This is, here we go. Here's where I print this. So basically the way metal works, the metal API, is you have this command buffer class. This is kind of up to how the application, how you actually want to structure this. But the way I've done it so far is you have like a command buffer. So this is a thing that basically just encodes a list of commands that the graphics card will execute when you commit it. So this here is in a function I just called metal command buffer commit, and I call this thing, and this is all kind of temporary right now because I'm still like, I'm in the rough draft phase of getting this implemented. So I haven't gone through and like actually clean stuff up yet. It's just like get it to work and then worry about that later. But I call this at frame end. So I have these functions. So this one gets called when the frame begins, and then this one gets called when the frame ends. And this is like a feature of the engine. The engine calls these. So when you begin a frame, you have to create a command buffer. So this is like, okay, this frame is going to have these commands in it. And then there's also this concept of an encoder. So like a command buffer basically it has a list of encoded commands that I guess live on it because, I don't know, I'm doing a bad job explaining this because I have some of this stuff hidden away in other areas. But basically, when you do this command buffer commit, this is like signaling that this is going to go to the graphics card, and the graphics card can actually start working on this now. And you can see here on the right side that like I submit here. This is where I print this. And then I commit down here. And then I see this finished. And these numbers are just the frame number, because I'm just counting incrementally from 0. So that comes from this here. And this is actually a signal that you can basically tell the command buffer to execute when the command buffer is done doing its work. So in other words, when the graphics card is done working through the frame, or working through its list of commands, it will asynchronously call this little function here, this scope. And this is like a lambda expression. And when that happens, it's printing that it's finished. And then right here, I have some temporary stuff where I'm like resetting the state of some buffers. And if you look at the right here, you can see that this is like kind of logical. It's like we submitted a frame, and then the frame immediately or subsequently finished. Like, you know, it's in order of submission finished, submission finished, submission finished. It only appears this way because I have vsync enabled, and basically the CPU isn't getting ahead of the GPU in terms of the work it can do. But if I go into swap chain init, this will demonstrate the problem. And I turn vsync off, which means basically just try to render as many frames as you can, you know? And then basically whether it's the CPU or GPU that bottlenecks, that will determine the frame rate. So if I run this now with vsync off, you'll see my frame rate is much higher, right? I'm in like 500. And this is even with printing a bunch of debug stuff. But now you can see that rather than having like a submit finish, sometimes we get 2 submits and 2 finishes. So it's no longer like perfectly, you know, back and forth between when things get submitted and when things finish. So I guess to put it more simple, all this tells you that the CPU has done 2 frames of work before the GPU has finished 2 frames of work. And this is a problem if you're not careful with how your CPU accesses memory that it's, I guess, submitting to the graphics card. Yeah, and this is the way graphics programming just works. And this is called, well, it's called double buffering. So like normally you have multiple frames in flight, and this allows like the CPU to just keep working and the GPU to work. And ideally, if things are running well, they don't need to synchronize. So you can see like here, like we're like 2 frames ahead on the CPU basically. And there's like modes where you can do triple buffering, so like it'll allow it to go 3 frames ahead. But it appears that Mac uses double buffering because that's the biggest case I see here is 2 of them. But if I draw a little diagram, this might clearly, oh, my eyes. Say we have a buffer. We'll have I don't know. We have a buffer, and we'll have the blue up here. We'll have like the blue area will be GPU, and the red will be CPU. So we'll like be on the bottom, and we'll put some frame lines here. Put some frame lines across the screen. Let me just make my little diagram. VSync doesn't, there is no direct relation. All VSync does is it enforces that the rate at which the GPU finishes frames, is synchronized with the refresh rate of your monitor. So it kind of artificially stalls the GPU. Like if the GPU is running like 1,000 frames per second, but your monitor only outputs say 140 frames a second, or let's just say 60 because it's easy. It'll basically prevent the GPU from, well, it can go both ways, I guess. It just ensures that the GPU doesn't like submit frames while the screen is refreshing. Because your monitor is also rasterizing, you know, from top to bottom when it presents an image. So if the GPU is like working on a frame, then submits a frame midway down your monitor's like refresh, you know, interval, you'll get like the top of the monitor will be from one frame, and then the bottom of the monitor, if it was just like interrupted midway through, will be like the next frame, and then you get the effect called tearing. That's what happens if the GPU doesn't synchronize with your display. Yeah, so like, okay, so here's my little diagram, and we'll imagine that this green block is like a vertex buffer. So say you're on the CPU, your CPU's doing work, right? It's like, maybe I'll put some labels here. So each of these is like, man, this is a horrible diagram. Bear with me. Bear with my bad diagram skills. So your CPU's doing work. Let's keep going. GPU. You have like frame 0, frame 1, frame 2. All right, so I'll make this a bit smaller because it kind of makes it easier to see. So in left to right would be time, right? So you can imagine, so on the CPU is like where all the game logic happens, like traditionally. Like say you're, I don't know, drawing some dynamic stream, like you have a bunch of sprites or something rendering. Your CPU in that frame will have logic that is building a vertex buffer that represents the sprites that are going to be drawn in that frame. So say it does that for a little bit, and then it finishes, and it submits a draw call. So it sends this guy over to the graphics card, right? And the graphics card, you know, now has this. And the graphics card works on it for a little while, and then finishes. So if this, let me zoom out. I wish I could zoom out at non-integer levels here. How come it's either 100% or 200? Yeah, I can't zoom in 150%. I guess it just doesn't like non-integer scaling in Paint. That's funny. You can imagine the good case is if, you know, both of these finish before the frame ends. Because by the time the next frame comes and I'm trying to write this buffer on the CPU again, right? This memory is safe to write to because the GPU is done with it, right? This is like the ideal scenario, is that, you know, there's no contention here. Now the problem is, since the GPU and CPU don't actually run in lockstep, you might have a case where the GPU is taking a bit more time, right? So like now there's an overlap between the GPU is still accessing this buffer up here at this time interval, but the next frame on the CPU is coming around and it's trying to write to the buffer again, right? Because it's trying to like, you know, it thinks it's on the next frame already. Oh yeah, I have a custom Windows installed that doesn't have all of the bloatware. So yeah, I don't have a lot of stuff. I also have like some crazy version of the calculator. But yeah, I don't have all like the Windows 11 bloatware that they try to force on you. But anyway, you can imagine the scenario where since the GPU isn't guaranteed to be done with its work by the time the next frame on the CPU begins, this buffer, this block of memory, is no longer valid on the next frame because it's currently being used by the graphics card. So OpenGL and DirectX 11, the drivers know that this is a common problem, right? So what they do is if you try to write to the same buffer on the CPU while it's actively in flight on the graphics card, it will instead give you a separate buffer that's safe to write to. So that rather than writing to this green one, you'll write to like this yellow one, right? And then, you know, the next frame, the green one's free again because it's no longer... Like by frame 2, you know, the green one's free now. And this graph is pretty bad. I have horrible proportions. But the general problem is that the CPU these aren't synchronized. So you don't safely know when things are like actually free. And in the lower level APIs, graphics APIs, it's up to you as the programmer to know this and write your code in a safe way. So what's nice is that this is just writing to memory that's mapped from the graphics card, basically. Because I was explaining that I'm working on Metal, and this is something that I wasn't anticipating having to implement. Excuse me, thirsty. Okay. So anyway, I have this debug stuff printing because this is a clear demonstration of this concept. It made even worse because the CPU is 2 full frames ahead before the GPU is finished. It'd be like if this diagram, you know, was like, rather than this green block over here, it's like this draw call finished, you know, way over here in terms of time, right? Let's just like get some, you know, love my paint diagram. It'd be like if this CPU frame finally finished here, and you have to juggle these resources. So basically the way the drivers do this is they, rather than allocating one buffer, they allocate a pool of buffers and then switch between them each frame. And there's different ways you can safely like validate whether the buffer is actually alive or not, or okay to write to or not. I'm just going to use a mutex lock for now. Even I think there are lockless ways of solving this problem, but I'm going to use a mutex. I have to get out of here. Okay, so where is my backend? Metal. Submit. Yeah, so anyway, like before I took out paint, took out the chalkboard. This little mechanism that Metal lets you do, exposes to you, is a way of knowing that a frame is done. And it's powerful because you can use this to basically tag your resources as safe for like writing again. So right now I'm just printing that, hey, this thing has happened. So I need to actually implement this stuff. But this is how you know that stuff is safe to write to. So we need to actually write some code. I'm going to write on my PC though. And then just sync over because I hate working through that remote desktop tool. Okay, so let's see. Where is my stuff? I have a lot of functions here I need to fix too. So, cool. Okay. It's crazy how many hoops you have to go through just to like render some stuff to the screen. I think it's crazy that it's like up to your responsibility to do this. All right, so I just wrote this. So I already implemented like a rough draft of this up here. So I actually need to copy this stuff over. So init free right begin. I actually need to add a function to this, don't I? So we need the current pointer, or the current and the offset. It's going to have to be asynchronous. I'm currently not managing them at all, really. But it will have to be asynchronous. Let's see. Yeah, here we go. Yeah, I do have a GitHub. It's in the there should be a link somewhere around on Twitch. Yeah. The whole source code's up. The stuff on GitHub's like a week old though, or a week or two old, because I don't push my like working branch up there that often. And all the metal stuff I've done. Yeah, why metal? Well, yeah, so that's a great question. So the number one reason, so I have metal working here, so it's not like it doesn't work yet. It's implemented. That's what I spent the last week doing. So why metal? It's because, well, one, I just have a MacBook and I work away from home pretty often. So I just want to like be able to run my engine natively on the computer that I use half the time. And the second part is that I might want to support iOS and like iPad as a build target. So like if I ever want to make an app that runs on Android and iOS, you kind of have to use metal, unless you want to keep yourself on like OpenGL 4.1, which is a problem because it doesn't have the full feature set of like the modern graphics APIs. So you kind of need metal if you want to do anything on the Apple ecosystem while still using modern graphics features. So that's why I'm doing metal. And right now I have kind of like the minimum viable subset of the graphics APIs by doing metal, because metal lets me run on Mac and iOS. DirectX 11 obviously lets me run natively on Windows. And then OpenGL is Linux. Now I could simplify it by doing metal and Vulkan, and then I cover everything with 2 APIs. But I haven't done Vulkan yet, so. And I already have OpenGL and DirectX, so that was my next step, is to do metal. And then after metal, I'll do Vulkan and probably deprecate OpenGL, because OpenGL is on life support, to say it kindly. All right. All right, so where was I? So wherever I call these buffer functions, you have to write your own vectors and matrices? I don't know what you're saying. Let's see. Okay, so then this double buffer thing I have here, this will become my managed buffer. So what I've called managed buffer here is basically just a buffer that can be allocated as a pool or a ring buffer. It's basically an abstraction upon the raw buffer, because everything in programming is just abstraction layers. Okay, where am I in it? So we initialize this thing. We free this thing. Begin. Yeah, I know there's legacy versions. I'm actually very intimately familiar with old OpenGL because I'm exposed to it a lot at my job because a lot of the code base is pretty old. And there's a bunch of different compatibility profiles and lots of stuff. The rabbit hole is deep with OpenGL. So this is something I need to refactor. This can be whoa, that did not copy. OpenG. Is that like pre-OpenGL? OpenG. Okay, so we also need this here as well. Current offset, current offset. All right. So anywhere I do double buffer, just change this to then okay, in theory this should all still compile. Yeah, it's, well, the globe's actually ellipsoidal, so it's like the correct, you know, the poles are a smaller, shorter radius than the equator, and the math is slightly more complicated for an ellipse. But yeah, it's rendered in like Cartesian. ECEF coordinates, Earth-centered something, Cartesian coordinates, whatever the jargon is. All right, so that still compiles. Let's commit this, and then the metal stuff might break. What'd I do? Discard. All right. So, resource. I already typoed this function. And 672. What is this upset about? Oh yeah, this access mode, I didn't pass that in, did I? Okay. Delete that. Why am I in this view? Yeah, so I mean, I have the most basic render graph, so I guess I don't really have a I don't really have sorting implemented because I don't have a full renderer implemented yet. I'm working on like the the low level engine graphics code right now. I can just show off like the very basic scene I have though that demonstrates the capability of that. So I have this project. I don't need address sanitizer on. GL clear. So this is like my graphics test project, and this is like really, really rudimentary graphics. But I did this on a stream like a week or two ago, where like I'm doing the classic sorted transparency thing. So if I render dock this, and I step through the draw calls, I don't know why. Is there a way to turn the filtering on for this? How do I filter to just draw like actions? I messed up something in my DirectX and now it's just showing me everything as like some huge list. Well, the premise is that all the draws are like sorted, right? Obviously, from back to front. So the way that works in my engine. Now, of course, a real renderer, you would sort things in a lot more like complicated way because, you know, a real renderer has more than just, you know, sorting transparent stuff. You like want to sort based on state changes of the things you're drawing, right? Because you not only do you want to draw like, you know, front to back if you're opaque because that's like cheaper for the depth test. But you also want to draw in a way that you're not churning through depth, like state changes. So it's like a delicate balance between sorting based on what is the minimal net state change between your things, but also preserving depth. So yeah, let's see. I need to find the project. Here it is. Runtime, scene. So the basic idea is that it's not my engine, it's not my core engine's responsibility for sorting things, right? It's up to the game to sort stuff however your game wants to sort things, right? That's just like the general philosophy for my engine at large, is that like the engine is just like a platform for interacting with, you know, user input, the graphics system, windowing, audio. That's it. That's all it does for you. It's a build system. But my render API, I have a render graph class, and I also have render commands, they're called. So these are like your actual draw calls, your pipeline state. So like, here we go. So this command that we're looking at here, or actually, let's see, this command here is like the render command for drawing each of those little transparent quads. So like here's like the actual draw call for that, you know, just a quad. And this is just like very rough code, just demonstration. But you create these commands, and then you set the, you know, the render state, you know, what's the shader, what's the depth testing, what's the write mode, you know, what are the blend modes, those would be part of this. And then we give it some work through this function. And by putting it directly on the render command by this like command.work, this is a deferred chunk of work, right? So this function isn't calling immediately. It's like we're storing it on this render command to be drawn later. So then we add the command to the graph, right? And then down here, we sort the graph, and the graph just lets you write your own sort function, right? So here I'm doing a basic distance sort, right? Where the sort function expects a left and a right, you know, an A and a B, because that's what you're comparing. And I'm just sorting by distance. And then that finishes, and you can see like, here, let's go into release mode. Sorting's pretty efficient. So like here we go. It's sorting all 256 of these like glass panes by distance in like a hundredth of a millisecond. And then it executes the graph. But the neat thing about this is that you can see here in my sort function, I get the render commands as like my left and right. And then to actually get the distances that I'm using to compare, I'm doing this get tags function call on these commands. Now, what are tags, right? Tags can be whatever you want them to be. So in this case, my tags are a double. And why are they a double? It's because up here, where do I do it? Set tags, here we go. On the render command, I called the set tags and I'm passing it a double, right? So this is like, hey, this command also has some payload that represents some state that I can sort with. I add GFX. GFX is just my graphics abstraction layer. So like anything you see GFX : that's just like my graphics API for the engine, I guess. I don't know how else to explain it. But yeah, so the cool thing is like, if there were other criteria that I would want to sort my draws based on, this could be, rather than being a double, a distance, you could make this like a struct, right? Like I could pass a mini struct that has other parameters that I care about. And also through this, I have like, I can also sort based on, you know, a dot pipeline. So here we go. I have access to the pipeline state that describes the GPU state of this draw call. Here's the pipeline description. So you have access to all of this information. You have access to like the raster mode, the call mode, all of this stuff. So if you wanted to sort based on, you know, relative cost of like state change, you could write a sort function that does that. So yeah, the idea is that it's kind of up to you to write your own sort function for your graph. And I haven't wrote it yet, but I'm also going to write a render graph filter function, which lets you filter out render commands based on whatever you want. And the cool thing is that this is, like I said, it's really fast to do this. And you could also do this in parallel if you wanted as well. I don't have it working in a thread safe manner yet, but it at a high level, it's such a simple system that it's like trivial to make this safe, thread safe. So that's a to do as well. Yeah. See, cause yeah, I just wrote all of my own API code as part of this project. It's like my goal is to just do it all myself because I wanted to learn. So yeah, I didn't use any of that stuff. But the benefit then is I have like no dependencies on external code, so it's a trade-off. But I spend a lot of time like doing stuff that you could just do immediately if you use GLM. Okay, back to the buffer work. Did I ever figure out why this wasn't compiling? Standard who? Oh, hey, I didn't even see you join the chat. Welcome, Dr. Elliott. I was looking at your engine the other day too, actually. I checked out your engine, Lumina, I think it's called, right? That's pretty cool. All right, let's get back to work. I can't stream for as long today either, by the way. I'm not doing an 8-hour long grinder like I did the other day. I have maybe another hour or two in me. But I was hoping to get this stuff fixed up. So what's it mad about? GFX resource count. All right. GFX resource count buffer. Macro redefinition. Oh, do I use this thing twice now? Yeah, I think I do. So we want to delete that. guess we can delete that. Yeah. Yeah, I'm realizing, yeah, I haven't done Vulkan yet, so I don't know exactly how the two APIs translate directly, but through doing this metal graphic stuff, I've realized there's a lot of stuff I need to actually start thinking about. Yeah, that's what I'm working on today. What's this? I just need to change access mode to something else. Yeah, because I should really just look at Vulkan next. Maybe while I'm on a roll here, I should just do Vulkan too. It's such a project. Resource at capacity. What? What's it mad about? Should really have done this before. Yeah, like right now, my ultimate goal for tonight is to get this, implement the concept of a buffer pool into my metal backend, so I can just safely do all of the assumptions I was doing with how I was writing two buffers. Just do it exactly the same as what my OpenGL and DirectX 11 code was doing. Because unfortunately the drivers for DirectX 11 and OpenGL were doing a lot of work under the hood that it is my responsibility to do now. And yeah, that's a good time. Okay, so come on. Really? Yeah. I mean, DirectX is like that too. I guess you say keys. Do you mean like slots? Because I know in OpenGL you have to like, well, in the later versions of OpenGL you have like explicit layout binding, so you can like, instead of getting uniforms by their name, you can get them by like their layout binding, which is like their slot. But yeah, like, yeah, I know what you're talking about. There's a, yeah, you could, like, you get the uniform in like the texture samplers and stuff by name, and it like literally just greps the source code for the shader and finds like, you know, which location is this in the shader? Yeah. Yeah, I think I'm not concerned about that. I think that'll translate well, because I've already bridged that gap in my engine. One thing I'm really looking forward to as well, getting to metal, is that I can, by getting off of OpenGL 4.1 or whatever version Mac stopped supporting, is I can do bindless textures as well. It's just like bindless resources in general. Yeah, I do slots. So like if you look at my shader language actually, yeah, I've thought about this a lot. Let's go back to Windows because it's a pain. Man, it's hard to jump around. Globe, let's go to the Globe project. Yeah, so in my shader language, I've thought about this. Is that like, so like my uniform buffer, and when I say uniform buffer here, it's literally just like a buffer, right? I just call it uniforms because I like the idea of uniforms being things that are like, can frequently change between frames or draw calls. But like in my language, everything explicitly takes a slot. And like since this is just a buffer under the hood, like the slot is just the buffer. And like the textures, see right now they have a slot because it needs a binding, but hopefully with bindless textures I can kind of remove that. Yeah. Any random in the shader? No, I don't have any random functions. I don't know. I've thought about it. I guess I personally don't have a lot of experience using engines that have an editor. Because I don't know, I've just basically my entire programming career has just been like writing code, right? So like in the job I worked at in AAA, they had their own engine that didn't have an editor besides like the map editor they used that they had in-house. So it's actually just not something I have much expertise on. So I'm hesitant to like make an editor because I don't know. I'm just not experienced with editors, so I don't know what like a good editor has. But maybe at some point I will, because that could be fun. What was I doing? So I have all these stupid compile errors. Let me fix this. Use of undeclared identifier capacity. What is going on? Where? What line? One 552. Oh, see, I passed this thing a size, not a capacity. Should be a capacity. Let me guess, I do this down here too. Size. An oscilloscope. That'd be cool. All right, let's see. Come on, just compile, please. What is happening? What do we mean I don't have API buffer free? Did you mean? What? This is such an anticlimactic stream right now. So is that function not just right there? It was pretty young. I was pretty young when I first got into it. So I'm 27 now, and I started programming when I was 9. So yeah, it's been a while. I'll say that my first like 5 years of quote unquote programming weren't that productive because I was like literally a child. But I've been exposed to it for a long time. Okay, so what do you mean undeclared identifier? Did you mean yeah, I guess I did mean core GFX. Okay. Some people are shocked by that. Apparently I look younger than 27. All right. All right, we're getting close. I think this is the final error. Yeah, I know. I don't know if that's a good thing or a bad thing. I get that all the time. Oh my God, what is happening? Buffer, undefined symbols. GFX buffer release referenced from, what? Oh, I see what's happening. Did I delete that function? Yeah, I must have. The titanium dioxide. All right. Oh, come on. I think this is my last error though. As I hit like 5 more. I didn't think this would be such a hard refactor, but it's because I don't have autocomplete. I can't select and replace. I have to like backspace on my own, like explicitly. It's just been a project. Okay, so let's see. I want to initialize this thing. Let's release. All right. This has got to be it. Come on. There we go. We're in. We're in. How come I'm not seeing these little asteroid things coming in? Oh, there they are. Maybe I should. Yeah, I'll think about doing that. That could be fun. It would be cool if there's like a place where we could all like share what we're working on and stuff. I would be down for that. Okay, so now that we got that done, let me just commit all these changes. And now I go back to Windows because it's so much easier to work on Windows. Where am I? Source, backend, graphics, metal. All right, so manage buffer. So I need to make some changes to my API assumptions here. So my idea for this managed buffer class thing is that it basically emulates what you can do in DirectX when you have a vertex buffer, or just any buffer, I guess. And in DirectX, you pass the buffers these usage flags and these CPU access flags. And these usage flags are basically, let me see. It's all of these. So when you initialize a buffer in DirectX 11, I should say, you can specify basically the usage pattern that you expect to use when you like actually use that resource. So you have an immutable buffer, which is like, basically you create this thing once, you write to it once, and then you're not going to change, like you're not going to change it frame, like within the frame or like frame to frame. It's like a write once, now it's, you know, immutable, constant, persistent. And then the other one that is important is the dynamic usage. So this is like, you intend to write to the buffer or overwrite the buffer on a frequent basis after you create it. Yeah, so this is like telling DirectX that your usage pattern that you intend in their drivers needs to be, you could say thread safe, I guess, because you could think of the GPU as a separate thread, because it kind of is. So yeah, that's what that's about. And then you also have these CPU access flags, which yeah, it's, where do I use these actually? Where do I use the map flag? Oh yeah, you have these mapping flags. Hey, how's it going? Welcome to the stream. Yeah, so I'm emulating. Realistically, it's just for learning, I guess. I mean, I created it because I just want, well, one, to just learn how all the random parts of game engines work. And also it's cool to have just this little thing that I can program stuff in quickly and easily. So it's just, I don't know, it's just a fun project. Not a product. It's too big of a project if I wanted to turn it into a product. Yeah, so I'm basically, my manage buffer will emulate basically this behavior, the mapping behavior and the, I guess, the usage flags. Because I use these for various things. When am I switching to Vim? I don't think I will. I've tried. I did try. I gave it an honest effort. But I rely too heavily on the mouse. I'm a point and clicker. I'm a point and click kind of guy. If you can't tell, I spend a lot of time scrolling around trying to find stuff because I'm not good at key bindings. That's actually one of the one thing I'm not good at is remembering key bindings, hotkeys and stuff. Okay, so back to the manage buffer. And yeah, so I created this manage buffer concept, and then also this buffer, which lives under the hood, because the manage buffer is just a wrapper around safely managing buffer resources. So right now I've gotten my Metal API, my Metal backend to work for like basic sprite drawing. And like it supports basically everything. It supports my little terminal, my little console up here. It supports my little UI elements. But this is actually just emulating one of those permutations of usage state. So I need to make this more robust because I won't always be using that, I guess, permutation of usage pattern. So let's see. Yeah, so I've also made this little GFX write mode enum, which I intend to map on those concepts. Yeah, so I have the concept of you write once. So this is like that D3D11 immutable flag. And I have a write overwrite, which means that, you know, if you have a buffer and you've set it with this flag, it's like I'm telling my graphics backend that I'm probably going to take this buffer and try to write to it multiple times, either during the same frame or in sequential frames. And then this write offset ring is like, we're going to write to this a lot, but every write should treat the buffer like it's a ring buffer, where each write is like at a new offset position in the buffer, which is actually an optimization usage. So use this for like optimized drawing of sprite batches. It's kind of like the main one that comes to mind. So right now I have my buffer implemented to just act like this one, but I need to make it more robust. So less yapping. Yeah, ring buffers are crazy. No, I don't have tiling. No. All right, let's see. All right, so yeah, I've been doing a lot of yapping. Okay, so here's my metal backend, and this is my manage buffer right now, the current implementation. This manage buffer resource is just a wrapper around an array of buffers, which are these guys. So these are like the actual GPU allocated buffer resources that like metal will allocate. And a wrapped buffer is just an array of those. And this double buffer count is something I'm going to change now because I don't want it to always be 2. But the idea is to support the dynamic usage and the fact that the frames aren't always in sync with each other. Like you see this green buffer from the CPU, it might draw way over here on this frame for the GPU. So the next CPU frame needs to access a different buffer. Otherwise, you know, you'll corrupt the memory that the GPU is trying to draw. So you need multiple of these. Now, a simple case is you double buffer where you just swap between 2 of them. But if your GPU is more than 2 frames behind, right, double buffer won't do you, won't do the job for you. You might need the triple buffer. So, yeah, it should be more than just a double buffer. So I'm going to rename this to be like nothing actually, or let's see, we'll be like managed buffer pool count, pool max. So this is like the maximum allowable number of, you know, pooled buffer resources. And we will we'll enforce a maximum just because it makes the code simpler if you just have like statically sized arrays of things rather than allocating this dynamically. It's easier just to have like a limit. Because realistically, I'm never going to need more than 8 of these, probably even more than 4. But then we'll also store the, I don't know, the, say buffer current. And then we'll have like the buffer count is 0. So anywhere that we were using this double buffer count, we will instead loop over the resource buffer count. So we're basically going from hard coding these to being something that you as a programmer could decide how many buffers you want to be pooled in your resource. So that solves that problem. So when we initialize this thing, which we do API buffer init, you might also pass it the buffer pool count, or like, and we can set that to some default value maybe. Let's make sure we do this on everyone. This is the annoying thing with supporting all these graphics backends, is you need to make sure these are all in parity with each other, otherwise you'll just get compile issues that sneak up on you. And so we'll like set this to, oops, wrong place. I guess for now I have to put a to-do here because I need to refactor a lot of stuff actually. Do I not have access to these? So we'll set it to a ring buffer and we'll give it, I don't know, 3. We'll have it 3 buffers in the pool for the vertex buffer, just for now. DLLs. I agree. I agree. Okay, what's next? So that solves one problem. Well, it didn't even solve a problem. I just did a refactor. Just make sure I'm not using GLM. Yeah. I hate dependencies on things. If you can't tell with my code base, I hate when I have like random things that my program relies on in order to run. Obviously you can't avoid them all. It's not really practical to avoid them all. But GFX. Let's just put this up here. I don't know where else to put this for now. I don't even know what that means. No max, no min. Oh, I see what you're saying. No max, no min. My brain read that as like one big word. I was like, what is happening? What does that mean? No max, no min. In this context. I will be enforcing a max and a min actually, if that's what you mean. I'm just going to assert that this is greater than, equal to 1, and less than. Yeah, because otherwise that'll be a sad day. Suppose I could make this a U8. Why not? Less data is better data. Yeah, I kind of want to stop doing this dual stream thing because it's confusing. But I have like an equal number of people that join in on Twitch now and also YouTube. So it's tough. So that's why I have the chat on the stream. So it's maybe possible to bridge the gap. Okay, let's make sure this still compiles. And refresh. Be a miracle if this works, because I always mess something up. Of course. What? Doesn't know what pool count is? That's a lie. That can't be true. Did I call it like capacity or something? Oh, I call it buffer count. Of course I do. Maybe I should have consistent names for my variables. Yeah, I am doing sorting. I actually explained that a little earlier in the stream, how it works. because that project you just saw, this is like my graphics test project as I've been developing the API. Just kind of like hack stuff together in here, which is kind of fun. Like I could turn on the snow particles, which are cool. Oh. I guess the snow doesn't work. What? I might have broken snow, it appears. Really? Wow. Okay, I broke snow on DirectX. I'll have to fix that. You see a lot of reinterpret cast. And what are your opinions on reinterpret cast? Is bitcast a thing? I don't even know if that's real. Bitcast? STD bitcast. Oh yeah, this is part of the standard. It's not built in C++. It's a standard library. I completely disagree with you, actually. But don't worry, I won't get too passionate. I'll explain though, briefly, because I have to finish what I'm doing, otherwise I lose my train of thought. So my project doesn't include any of the C++ standard library, and the main reason for that is I wanted fast compile times. So in the sake of my obsession with fast compile times, I have stripped basically as many dependencies as possible from the code, and I've basically implemented everything from the bottom up, which means I'm using my own containers for things. And yeah, so that's like why I'm not using the standard. Well, upon other reasons, I don't think it's really necessary for most of the stuff you do. And I have a C background, so I don't even really use many of the modern C++ features. Besides templates, in certain areas, I like templates, and I like namespaces. That's probably, and function overloading, and I guess references. Those are like the main features I like from C++. Templates, function overloading, pass by reference, and maybe lambda expressions too. I kind of like lambdas lately. Now, reinterpret cast. Reinterpret cast is not memory unsafe. It's memory unsafe if you don't understand how the underlying memory of computers works. The only times I used reinterpret cast are areas where I know 100% that it's safe. For instance, I use reinterpret cast when I'm using opaque pointers, which I use in certain areas so that, like for instance, I use opaque pointers in my graphics backend so that each graphics, like my front end graphics code that like the user interacts with in their game code. You interact with my graphics API, but my graphics API under the hood has to interact with DirectX 11, it has to interact with OpenGL, it has to interact with Metal. And the bridge between those, the front end should not know the implementation details of the back end by design, right? Otherwise, you have to include back end headers in your front end code. But you need to bridge the gap somehow. So you bridge the gap by using opaque pointers. And what's an opaque pointer? An opaque pointer is basically a pointer that either decays to void, but you know the type, so you can reinterpret it back, or you just don't implement. So I use reinterpret there. I use reinterpret in custom data structures because you store memory as just bytes. But when you actually want to use them in the type system, you obviously know based on the rules that you've programmed in your allocator that the memory at this position, at this offset and this alignment is this type, that's perfectly valid. And you've called the constructor on it at that location using placement new. Like, you know that the lifetime of this thing is valid, the memory is valid, the alignment's valid. Reinterpret cast is perfectly safe to do. So people are like really afraid of using reinterpret cast as if it's like some boogeyman. It's perfectly fine, and it's really useful if you just know exactly what you're doing when you're using it. So yeah. And if you look at like under the hood, a lot of uses for a reinterpret cast, the compiler knows exactly what you're doing anyway, and will take your reinterpret cast and do, you know, whatever type safe, you know, op that it needs to do. Nil is that's Objective C++. That's because I'm working with metal code here. Yeah, sorry. I know you might have joined midstream, so I'm kind of rambling. I'm working on Metal Graphics API for macOS support right now. And the Metal Graphics API is an Objective-C API. So in order to compile to basically use the Metal API in its native true form, you have to use what's called Objective-C++, which is like a hybrid language between Apple's Objective-C and C++. And nil is the keyword that Objective-C uses for a null pointer, or just null. And that's why you'll also see like some weird stuff in here, like this crazy stuff here. So yeah, that's my passionate spiel about reinterpret cast and type safety. Don't be afraid of casting. It's not scary. And it's not unsafe either. But you can do unsafe things with it, right? It's like a knife. It's a knife. It's like you don't want to run with a knife, because if you trip, you might stab yourself. You don't want to run with your your pointer casts. But that's also why you run the address sanitizer too, because like you can run asan and it'll catch a lot of problems. Reference pointer, reference wrapper. Yeah. Okay, so what was I doing? I just got completely sidetracked, which is perfectly fine. Let me see. Where was I? I was working on the buffer pool thing. Yeah, so I'm implementing. See, this is fun because I have to do some like thread safe stuff here. Let's see. Because, okay, so I have to go back to my managed buffer class. No, I mean, I'm also just I'm just yapping too. Like I'm not actually that passionate about any of this. I changed my. Well, I'm kind of passionate, but I'm not going to like advocate that my way of programming is like the correct way. I'm not like that passionate about it. I do think my way of programming is one of the valid ways though. And I'm just going to continue doing it because it works for me. But like, you need to be consistent with how you structure things. Otherwise, yeah, you'll run into problems. And the benefit of working as just a single person on this project is like, I have full control over, you know, the standards I use. So it works for me. Yeah, I actually see. I agree with that too. Like I put a lot. I basically const everything by default because I actually hate the concept that everything is mutable by default. I wish C++ would. Well, I know it's a huge ask for C++ to change this because it's so fundamental to like the language and backwards compatibility. But like, if you ever think of like the control flow of a program, there's like. Most things aren't mutable. right? Like most of your state is like constant in most places that you use it. Because like most of the things you do, you're like reading memory, you're not writing to it. Only in certain areas do you actually like mutate the state of things. So it's weird that by default, everything is mutable. That's something I also feel strongly about. Oh, and the other thing I want to change too while I'm looking at my code is in my graphics code, I've done a quite liberal use of the pointer reference. And I don't like that I'm doing this, so I'm going to change this at some point. It seems like a weird idea to be passing a reference to a pointer because it like implies that I'm going to be changing, you know, the value, like the pointer itself and what the pointer points to. Yeah, so it depends. Yeah, I can show some of this. So like what we're looking at now is kind of a weird case because I don't really do this anywhere except for this graphic stuff. Is I have like this resource, which is just some struct with data on it. And then I have these release functions. So like if I look at a release for like, I don't know, GFX texture release, resource release. Like my release just makes sure that, you know, Metal has released its texture resource and that this resource is then removed from the resource pool because these are like pooled resources. And then I set the pointer to null here. I want to change this because it's kind of, I don't like this. Yeah, so nil is literally just the Objective-C null pointer. Well, it's not actually. Well, it is, and it's not. It's because Objective-C has classes, right? Like objects, like this MTL texture thing. This is an array of textures, and I'm like looking these up by IDs. So if I go to like what this actually is, where do I define this thing? Static. No. Here we go. So like, okay, so yeah, this is the array of my texture resources. In my engine, I just have like a maximum pool size of textures that can be allocated, and it just reuses slots based on like, you know, I'm just reusing memory, so I'm not like dynamically allocating things. But yeah, this is a Metal API resource. So it's this ID, you know, open. It looks like a template, right? It's like an ID template, but this is actually an Objective-C concept. So this is an object in Objective-C, and this is the object type is an MTL texture. So everything in Objective-C, all of the objects, they're reference counted. So basically, the lifetime, it's kind of like, I mean, a lot of languages are like this, where like you don't explicitly malloc things, you just, they allocate them and then it's reference counted, and when the references go to 0, it's freed. So Objective-C works like that. So the Metal like graphics API is internally doing the reference counting for these textures. So when you set one back to nil, you're subtracting a reference from that object. And then internally Metal will, you know, determine that, yeah, the auto resource, yeah, you have the, yeah, you've got it. You have the resource pool. Yeah, pretty much. Yeah, because Swift is what, you know, Apple is trying to, I guess, kill Objective-C. Yeah, auto reference counting. All right. Yeah. It's interesting. I'm not an Objective-C guy. This is like, my exposure to it is whatever I've had to do for the Metal stuff here. And I also use it for the window on Mac. When I initialize the window, you have to create a Cocoa window is what the window API in Mac is called. And you have to use Objective-C to interact with that as well. Yeah, so you have these weird, like, here's like like a function call in Objective-C, which is some crazy syntax. Where'd you see that? I don't even know where you saw that. Const void const. Oh, here we go. Here we go. The const void pointer const data. Okay, so this is a non-templated write function. So rather than passing it the type, you have to pass it the pointer to the thing that you want to write, and then the size of that thing. And you could delete the const here because it doesn't actually matter. But this is just telling me in this function that I am not going to mutate this thing. I'm not going to change what data points to, and I'm not going to change the contents. I'm not going to change the pointer data either. It's just like an overly verbose way of saying that this thing is just going to pass right through this function in its, you know, pure unmodified form. And that's, you know, that's the C++ thing where like you have, when you know, when you do a string, you do like a const char pointer. This is a C string, you know, string equals like test. Right, this is a C string. So you're initializing a constant char array, you know, pointer, and the string points to that array, right? That's what this is telling you. Now, if you wanted to, with this syntax, it's not saying that string as a variable is constant. It's saying that the contents, the string itself is immutable, right? So if you want it, like if you wanted, you could at some point later, like reassign string to be something else, right? And this is perfectly valid because it's not the string variable that's constant, it's the data, right? So this is valid. If you wanted it so that you can't modify what string points to, you have to do another const after the pointer. And that's like the way that you do that. So like if you had a char pointer constant, what this would be saying is that I can't reassign string to point to something else, but I could mutate, you know, the first letter of string to be like, I don't know, B. And now this string would say best because I'm allowed to mutate the char array, which is like this thing. So that's yeah, that's some fun stuff. That's what that means. All right. So buffer resources, GFX buffer. I mean, yeah, it's very verbose. The thing is, it's like almost laughably, it's like laughably verbose, and it's like it always trips up beginners too. And like it took me a long time to like actually intuitively understand what that meant and be able to read the code and understand it. But it does make sense once you understand what's happening, because the language has to provide some mechanism for describing both behaviors, because sometimes you want one case but not the other. Sometimes you want neither case, and sometimes you want both. And yeah, and I think ultimately C tries to be backwards compatible with C++, or like C++ tries to be fully compatible with just raw C. And this concept comes from C. It doesn't come from C++. The const char pointer const thing, that's like a C concept. So for C++ to be compatible 100% with C, it has adopted that syntax. And they could come and invent a new syntax if they wanted to, I guess. But you could argue that clutters the language because you already have a way of describing the behavior you want. So should it be a core language feature? I don't know. People would disagree, would argue about that. All right, so I need to have like a U size in here, or maybe I'll say like frame. Let's call this thing frame for now. Okay, so what I'm doing for reference, I'm kind of jumping ahead. This manage buffer resource, basically, if I send this thing to the graphics card during a frame, it needs to be marked as like unsafe to mutate or unsafe to reset until the graphics card's done using it. So the way I'm going to do that is I'm just going to store the frame, and there's probably cleaner ways to do this. You could store the I guess swap index, the double triple buffer index or something. I'm just going to store the frame for now because it's easy to change, but I'm just going to store the frame at which this thing is actually being used is what this will represent. So if I go to let me think. Yeah. If I go to wherever I draw, so wherever I use this actually. So, okay, so here, this is some metal code here. This encoder, Objective-C stuff. This is at the my draw call function. When I draw, obviously you bind a vertex buffer to draw, and you add it to this encoder list, which basically tells it, hey, next time that we commit our work to the graphics card, this vertex buffer is going to be bound and we're going to write to it. So wherever we do this is where we know that this thing is going to be dirty, this frame. It's going to be in flight after this frame. So I guess we want to do the GFX get buffer. Right now I just use floats and doubles for everything. I know that will be a problem with networking. If I ever like network stuff, like a simulation over the network, it's going to be problematic because floating point isn't, well, floating point is deterministic, but it's not deterministic in like a nice way. So yeah, having at least supporting fixed point math, at least if that's what you're talking about, because I've thought about that already. All right, let's see. Yeah, actually, on that point, so I have this game, my Terraria clone. Hold up, let me compile this. Here's my Terraria clone. So I have this game I was working on in the engine for a bit. I have this water simulation. This is loud. In this game. And I'm actually doing this simulation on the GPU. And I wanted this game to have multiplayer. And one of the big problems with multiplayering stuff or networking a GPU particle simulation. Yeah, bot. Every couple hours I get a bot that joins in and starts asking for viewers. Yeah. Eventually I'm going to need to network this simulation, and that's going to be a pain in the ass because one, I'm doing it on the GPU. So it's like already, has that going against it, but then the math for the physics is actually floating point. So it's like, not only is it floating point math for the simulation, but it's floating point on the GPU. And unless you explicitly turn on like whatever setting it is to guarantee deterministic floating point operations on a GPU, Yeah, I think the bot message is gonna stay up unless I can delete it. See, I delete them here, but they stay. Oh, they do delete from the stream. Okay. Well, it deleted from the live stream. I'm not on Twitch there. Let me see. Let me see if I can delete this. How do you delete? I don't know. I'm just gonna keep it there for now. Yeah, so yeah, that's gonna be something fun to deal with. Okay, so anyway, I need to, how am I doing this? Buffer. So I'm doing GFX. And yeah, I did see the message about the the void const pointer const. It is compatible. Yeah, so 4 a.m. Wow. Oh yeah, you must be in Europe then. Eastern Europe? No. 8 hours? Is that 8 hours? Wow, up late. It's only 8 o'clock for me in the evening. But yeah, I know it. Yeah, it is compatible, I think so. I over const sometimes just because I like const correctness. Yeah. Oh, that's right. Yeah, we get the clocks changing soon too. I wish they'd just end that because I'm sick of that. Okay, resource. Buffer. Okay, so get the resource there. And then let's see. It's kind of annoying because now I have like 3 layers of indirection between my actual resource my code's interacting with and like where the data is, because we have to go through this like memory safe layer between the vertex buffer and the actual buffer that's going to be bound to the draw call. So we have our resource vertex, or resource, let's just call it managed. Our managed resource is this thing. And then we also have just our buffer resource, which is like our resource buffer, which we do managed buffer, current buffer. So this will get us the current buffer that this guy has. That should, we also have to just spam asserts everywhere because you never know. This is another way to make sure your program's actually in a good state, is you just spam assertions everywhere you go, because that's a good strategy. Yeah, where I used to work at, I don't know. It's annoying because of, NDAs and stuff. I can say generally at the AAA company I used to work for, their whole code base was very like strict about everything is const unless it's not, including function parameters. And I know objectively, like, because I've looked at this with, the Godbolt, compiler online where you can actually inspect, the output assembly, that doing const on function parameters it compiles to no different than just not having const. Like const correctness as an optimization for like performance is just fake for pretty much every case except a few. So it's certainly over verbose in a lot of cases. I just think it's good for like API standpoint and like as a programmer to know when I glance at a function, like I can just look at my function parameters and just at a glance, I know what is like just data that's being read and what's something that I might be mutating without having to actually read the function. And especially so if it's code I wrote a while ago or it's like an API I'm not familiar with. I just like seeing that information because it just helps me read code faster. So like, yes, it doesn't compile to code that's any faster, but I think it's like, it's useful information to have if you just write it out. But maybe I'll change my opinion on that eventually. That's my take on that. Okay, so we get the resource. And now this is the thing we actually bind. So we have to assert this, assert that. Yeah, pretty much. And yeah, that's why it makes no difference is because, yeah, like in assembly, like you ultimately put things in registers, right? And certain registers they're like read only, they're inputs. So if you have like a value that you're going to mutate, you specifically put that, in certain registers, right? Depending on the operation. Okay, so I think we're going to need locks around this stuff, so I'm going to put it to do like thread safe lock. But for now, we have access to this resource buffer. Dot frame, we have to do frame current. This is it to do. Oh, my microphone just glitched out. 1 second. Every so often my microphone drivers like break or something. Okay, so we need a constant up here somewhere that's like and then frame begin, or I guess frame end. Where'd my music go? All right. Yeah, that's a good point, actually. Yeah. The mutable thing. It's an interesting topic. Hey, how's it going? Welcome to the stream. All right, so I have the static frame index. This would be frame current, frame current. I'm streaming on both. I have a dual stream going. VNC, no, I haven't. VNC server. What is that? Oh, is this a alternative to my remote desktop tool? Yeah, I'm using this one called Rust Desk. Yeah, I have Rust Desk. Oh, and now my screen went out. Everything's just falling apart here. 1 second. My stream is just decaying as we speak. There we go. We're back. All right. So what do I do? Frame index. So like this is just our global frame that just counts up until the end of time, until it overflows and restarts at 0, I guess, which shouldn't break anything because if your frame goes past the uint64 boundary overflow, then you have been running the game for literally millions, probably billions of years. All right. Yeah. I wish I had my hotkeys. Yeah, if you go to, if you look at the bottom right of the screen under the chat on like the stream, that's my Twitch handle on there. So if you just go to that URL, you should find the Twitch version. Okay, so let's see if this still compiles, because that would be great if it does. Of course it doesn't, because I don't have that on the right class. Classic. What's happening? This should have been on this one. No member named frame. All right. Okay, so now I track the frame at which this thing was. Yeah, that's interesting. I should really learn more about assembly. I know the high level stuff, and I can like read basic, like I can look at, you know, generated assembly code and kind of reason my way through the control flow, or like the execution flow. But I'm by no means an expert. I still can't believe, I learned this recently. The game Roller Coaster Tycoon 1 and 2 was written by one guy in assembly. And it's like, what? Some guy wrote the whole game in assembly? It's insane. I don't know how true that is, like what that actually means. I just read that and I was like, wow, that's crazy. Especially for like 1995, whatever year that game came out. 99 maybe? Yeah, 99. Ah. Okay, so now when I free these things, see, I'm working my way up to this freeing of resources. Because here, I'll show the problem that I currently have right now. If I turn off vsync, and then so we have vsync no, and then we just run. Okay, I guess you can't see for some reason. I swear when I was doing this last time, it was flickering. Okay, it kind of does flicker every so often. Like if you look at the text, it's not doing it. I guess I'm doing a good job with my buffering, my double buffering. But there's flickering that occurs every so often. And the flickering is because I'm mutating buffers while they're in flight for a frame, because I wasn't doing this correctly. So if I go to command, buffer, commit, and in here, this to do here is what I've been working towards. So if the resource dot frame is equal to the captured, maybe I should name that to like draw frame index or something. Or I guess if it's not equal to this, we can just continue. Now this has to be this might have to be thread safe lock, because this can call asynchronously. But this should basically, because what was happening before I was checking is that every frame I was just looping through all of the active buffer resources and then reset them, reset their state so they're like writable again. But we can no longer make that assumption here. We should only be resetting the frames that they were submitted on, right? So that's part one. And then the second part is that when we actually go to write these things, yeah, I have a Linux computer too. So I have a MacBook. Obviously my Windows is my main PC. I have a Linux PC, and I think my Linux install actually just died the other day, so I don't know what happened. I've installed Linux like 5 times and then it just randomly dies on me. So I don't know if Linux is working. Let me see. I might be able to get Linux up and running. It's cool because I have a KVM switch as well. So in theory, all I have to do is press a button and switch my KVM. But now, of course, it's not getting any video signal. I had Arch, and my previous Linux install was Arch, and then I segfaulted when I was doing an update, a system update. I did like the sudo pacman SYU or whatever it is, I forget, and it was like updating everything, and then it like segfaulted during the update, and like my terminal was just filled with a bunch of garbage, and then I tried to reboot, and it just like my whole operating system was corrupted, which was pretty funny. All right. I was trying to get my Linux computer on, but it's not working, so, you know. Now I have to get back to my Windows PC. 1 second. The video should return in a moment. Here we go. We're back. So then I installed Debian, and that was working for a little while, and now it's not working anymore. Yeah, that's cool. Okay, so what was I doing? Buffer. Okay, so buffer count. Wherever I was doing this, buffer count. Okay, so this part is where I swap buffers when I'm doing like a ring buffer write. So I was swapping them here. And then this is like the next buffer it chose to write to. So we also have to because this isn't valid, because we're not guaranteed that the next buffer in like the pool, right? If we just increment sequentially, which is what this is doing, modulo by the count, we're not guaranteed that this buffer is actually safe to write on yet, because it might still be in flight. Like if we're a couple frames ahead on the CPU, it's like we might be in flight with that buffer still, so we need to check that. So I guess we can just keep incrementing until we loop back around on ourselves. And then in the case where we loop back around on ourselves, then we know that all of our buffers are in flight on the graphics card, and we just need to stall the CPU, because there's no like valid option to allow us to write in that case until we wait for the graphics card to be done. So I guess, I don't know how you even write this. So we need to like while I guess while we'll store the start index. So like the start is our current. Is a while even the correct loop for this? So what do we need? So I guess this loop should continue until the frame counter, I guess, for this thing. This will be my reset flag, as if these are maximum value. Or I guess 0 works fine too. Not equal to. Or okay, so we do this little loop increment thing. While, what's this? So buffer. I can store stall. I'm not sure how I want to structure this loop. Let me make the text a bit bigger so it's more visible. Okay, so I'm going to store 2 pointers actually. So I'm going to store the, what is this? This is a GFX buffer. So buffer is our current thing, which I already have up here actually. So I know that that's true. So we can say, here we're gonna do our const pointer thing again. It's exciting. So we know this is the buffer we started our little seek operation on, because we're trying to seek to the next available buffer basically. And we do that by just linearly cycling around the ring of buffers in our pool. So this is just our starting point that we will compare upon. So then while buffer is not equal to start, and the buffer dot frame is not 0. Actually, this would fail. Here, we'll do that. We'll break the loop. We'll busy wait in the loop if it is in contention, so. It should be a do while, I guess, because we need to at least go 1 iteration. So we do this while this, because our first iteration matters. Okay, so buffer equals So our current buffer index is this. I should name it current buffer index. This whole thing. Hopefully I'm getting my logic right. I keep changing how I want to represent this concept. Okay, so that's our index. Our buffer is the actual resource of that index. So then paste. So we iterate this thing one time at the beginning of the loop, always. And then I guess I'm just going to make this a while true loop, actually. Just an infinite loop that will break itself when the conditions are met. It's just easier to reason about a loop like that, I think. So if buffer dot frame equals 0, so it's not reserved by some frame, it's not in flight, then we can break. Cool. We found ourselves a good slot. Otherwise, if buffer is equal to the start buffer, that means we've looped all the way around and every buffer is in contention. Which is a bad, well, actually this should happen first. This means we looped all the way around, so we need to busy wait here. So I'm gonna put a little to do, like busy wait, or maybe like a lock for the GPU. And I guess it can keep cycling until one of them is true for now, so I don't actually need to lock. It'll just do this until this case is met. So the CPU, I guess, will keep itself in a busy wait inherently. I guess until, yeah, until the first one is free. And then if we escape here, we can assume that we've found a new buffer and we're in good standing. All right, that makes sense to me. I think that works. Okay, if this works, actually, need to buffer commit. We need to reset this. Okay, so if this worked, it should just look like nothing changed, hopefully, which is what we see. I'm looking for flickering too, and I don't see flickering. All right, so we can add to our print spam as well, just demonstrating which buffer is actually being written to for any given, so API draw. So when we like do this, we can we're probably not actually using the full ring either because our buffer is so tiny. But we still print this out. We'll just print it out in like yellow. So we'll print the which of our buffers in the pool did we actually use for that frame? In theory, these should change when we double buffer. Yeah, I think they might be. It's hard to tell. We're really getting bunch of spammed calls here. Yeah, okay, this isn't fully working. Let me see. Spam. Okay, so this is working, potentially. Actually, maybe not. Because why is this drawing offset? Unless there's no contents to this. Maybe it's like submitting a draw call with no size. Am I printing the right thing? It's hard to like reason about what's happening here. I don't think this is correct though, because we're not incrementing the offsets on these. These are. I need to divide this by the, so I have like a, how many vertices are being drawn in this given offset. So yeah, we're getting 0, 28, 28 to 56, and that submits. And then it's resetting after the submit, because that should be next frame draws, and that's oh, that might be a different vertex buffer. Here, let me just, okay, so draw frame. We'll print the frame, put the vertex buffer ID, and we'll print the pool ID, offset, count. So we have frame current, vertex buffer, All right, now we have genuine log spam. Okay, so frame 1421, vertex buffer 0, for pool ID 0, submits a draw with that many. So something is resetting this actually, because that's not, it's not incrementing reliably, like 24 to 56, 80 to 24. Like this is reliable, but the beginning of the frame is not. So what could be resetting that? For init, right begin. Init dynamic, static. Well, I'm not incrementing offset here. Is that real? For right. Well, that would be current. Yeah, so this should be. And then when we write again, well, I guess this is expected. Yeah, because that's always a frame delayed. Yeah, because the offset is its like begin right position. And that's right. Oh, and this should be current buffer offset. Let's see, right begin. Well, that's so interesting. I have like a draw in here that I don't even think should be in here in hindsight. This is like not the correct draw. And this one too. It's like I'm getting an extra draw where I don't expect a draw to be. Like what's 28 plus 56? That's 84, right? That's this one. And then for some reason I'm getting this draw twice. It's like drawing the last frame twice for some reason. That's really bizarre. Okay, but if I make my sprite batch really tiny, Like, what would split this into? Let's do like 128. That should split the batch, I think. This is where we should see the numbers change, or it just crashes. Really? Hey, how's it going? Yeah, here we go. Now we're getting some buffer right contention. Oh, and then we stall here. Look, we stalled. Did we crash or did we just lock up? That's the question. Now we should have eventually came out of that stall. So maybe we're busy waiting too much. I'll print like. Next time this happens, we should get spammed in the log that we're stuck in a stall. Yeah, here we go. We're stuck in a stall. I think this one's caused because I'm trying to write more vertex data than can ever fit. In which case I should be truncating it. Because yeah, I understand what's happening. It's because I made my sprite batch so small, 32 vertices, that if I had more than 32 vertices trying to submit in a single like draw call, there will never be a buffer that this can fit inside of. So it's not even like an issue with the it's stuck in this condition, I believe. Potentially. Though, in hindsight, I feel like that should be an impossible case. Yeah, it should. The intended behavior is it should just stall until the graphics card's done, and then one of these free up, and then it will exit the loop when that happens, like atomically. There should be an atomic read on this buffer.frame thing. I don't have like atomics in yet, so it could be like doing some weird race condition, but this is just a read, so I think this is fine. Because the only thing Yeah, I mean, this is probably fine the way it is. I don't think I actually need locks in like real scenario, but you probably have them just in case. So it's stuck in this case. So it's like this is never freeing. If I just break here, what happens? If I just, or if I return here, I just don't submit the work. What does it do? Yeah, look, it's like we have run out of buffer writing potential. So now it's just discarding the work of that frame until the GPU can actually like free up the resources by continuing like doing its frames. Because we're trying to just draw too much to the screen at once, it just can't keep up. Yeah, and like here I'm trying to draw too many glyphs. Now this is because I set the limit super tiny. Like I have control over this here. This is my quad batch size. So normally this would be like some large number. So this doesn't actually happen in practice. Yes, they do. Well, they can. If they have like a uniform buffer that's shared between multiple shaders. Well, it's actually, the FPS is worse than it should be because I'm doing the live stream and I'm spamming a bunch of stuff to the console. Like if I go to DirectX on Windows for the same demo, like check this out. Metal. I'll run DirectX on Windows. Let's get it into release build as well. Like, look, I get like 12,000 FPS on Windows. Less if I'm in full screen. Yeah. Yeah, and if I go to OpenGL, it's pretty fast still. It's not as fast though. Like it's about half. 7,000, that's not bad. Now on my Mac, I can make it faster. when I'm not doing this like remote desktop where it's like recording my Mac screen and I don't spam a bunch of stuff to like stid out, it's about 2,000 on my MacBook. So yeah. Anyway, I need to gracefully handle this case. And come to think of it, I'm not actually sure how I would best handle that case. This is actually tough because there isn't like a right answer here, I don't think. Because the issue is like I have so here's what's happening in this loop. Here's why it's flickering. I know exactly why it's flickering. So I set my sprite batch size to 32, meaning I'm only rendering 32 quads to the screen in any given vertex buffer. That's like the maximum number. So if I'm drawing a ton to the screen, it has to split that up into multiple vertex buffers in order to like render enough. And as like a temporary thing, I initialized my vertex buffers as a ring buffer with 3 like buffers in the pool. So if one fills up, it goes to the next one. If that one fills up, it goes to the next one. Yeah, I did leave the return there because if I don't return, it just stalls forever. And the reason it stalls is because, so say I have 3, I'm triple buffering. Say I have 3 buffers in the pool, each of them doing 32, like maximum amount of vertices. Say in any given frame, I try to render more than 32 times 3, 96 quads. Then that means all 3 of my buffers are full, meaning they're all going to be in flight to the GPU at any given time, meaning none of them are safe to write to. So this condition will never break because within this frame, I have used up all of my buffers, and there is never a new buffer that I can write to because they're all like utilized. But the problem is that I guess I would need to submit the draw here. I would need to like, where I'm doing this return, I would need to submit the command buffer to the GPU and then busy wait until the GPU finishes, I guess would be the way you solve it. Yeah. So how would I do that exactly? I guess the thing is, the problem is that I think this just has to be an error case that like your program should never encounter, because this is like an edge case that's unrecoverable, in that this function is the API call to actually write data to the buffer, right? So like the implication is that like this isn't a place where rendering happens. Like I'm not submitting draw calls here because this is just a buffer. This buffer doesn't know that it's a draw call, you know? It doesn't know that it's a vertex buffer. This is just a buffer. All the buffer knows is that nothing in the pool is free. So I think a return is actually the correct behavior here. It's like you would return and then warn. Yeah, but that's actually not the problem. The problem is that now let me think. Yeah, this code isn't a vertex buffer yet. This is used by the vertex buffer to write data, right? So like returning here is the correct method. It should just be like, if this returns false, that means it failed to write. And I guess that would mean the vertex buffer would, the only case the vertex buffer would fail to write its contents is if they're all being used. Yeah, so it is related to GL flush, but the problem is that I don't even have a frame to flush yet because I haven't even submitted the calls. I mean, yeah, I guess that is how you would solve it. You would just never run into this problem in your application because you've allocated more than enough buffers. So I guess I'm just stress testing. I don't know how the DirectX drivers handle this. I mean, you could dynamically allocate. I don't think you have to, though, for this. You shouldn't have to dynamically allocate stuff at runtime for, like, your buffers. I don't think. Maybe you do. Maybe you just chain them together until... I guess the thing is, if you dynamically allocate, you're not solving the problem. You're just pushing it down. Like, you're just pushing it over. Because, like, you could imagine the scenario where, like, your data is so large that eventually your dynamically allocated buffer, like, pool or chain reaches its capacity, and then it's like, well, now what? Now you're completely out of system resources. So like from like a theoretical perspective on like what this actually is encountering, I think yeah, well, yeah, the GPU can't free its memory until it's done doing the work that it's like queued up. So like the whole mechanism behind this is that I'm preventing buffers that are currently queued up for work from being mutated, is like what this even is doing. So I think returning here, I'll just like do a warning. So like we have like, I'll say pool capacity, because that's like a problem. Here we go, we're getting these warnings. Yeah. I think by returning, all we do is we like discard a write, basically. It's like we've attempted to write something and we don't have anywhere to write it to, so like we have to discard this write and sort of fail gracefully because we've like reached the limit of, you know, the system that we've allocated. And then like obviously as a system you would have a large enough pool where this is never hit, which is why I have control over this batch size. It's like if I ever hit this, I guess you just consider increasing the batch size or break up how you're rendering all of your stuff. Yeah, the value I'm setting is just arbitrary. This is arbitrary. It's ultimately like up to like how much memory do you want to allocate in GPU RAM for like your vertex buffer, or just like any buffer. So yeah, it's like if you haven't allocated enough memory, this is going to fail at some point. So I think I'm satisfied with that line of cope, that reasoning. Okay, I can remove. I guess, yeah, I see what you're saying. So like, I guess what you're kind of describing is like a grow buffer, I guess. Like if it doesn't have capacity, then we need to grow the buffer so it has capacity, right? Because like, if we've reached the capacity, that means our capacity isn't the correct value. So like we should grow it and then do that. I guess I could have that as like a setting. The idea is you need to be careful with like growing memory just arbitrarily, like, because I guess it's ultimately like what's your philosophy for how you program stuff. It's like if you only have a gigabyte of GPU memory and you're trying to draw more than a gigabyte worth of stuff per frame, then you're going to exceed the GPU memory and you're just going to have an insane frame rate drop because it like has to, you know, map it back to system memory to like handle doing that. And that's a problem. So like, I just prefer to have fixed budgets that you sort of predefine. Yeah, every card would have different. And it's annoying because you can't actually like query that information either programmatically. I mean, there are ways to do it, and there are like libraries out there that sort of have that can access that information. Because like ideally you would like find out the VRAM of the device that you have in your computer. Yeah, GTA 5 does it. It's probably because they have a library that can detect, that associates like the device ID with some database that knows the VRAM. Because it's not trivial to actually get that information, like at like a programming level. It's not impossible because obviously games do it, but it's like, yeah, that's harder than you think. Yeah, you can get it for the CPU. There is some you can grab. Actually, let me see. How is it possible? Maybe it is possible, and I'm just yapping for no reason. Let me ask ChatGPT, because ChatGPT always knows the answer to these questions. I can't type programmatically. So I'm curious the answer to this, because this would be nice to have just in the engine level to be able to get this information. Yeah, well, it is handled in the driver unless you're in the modern graphics APIs. Then it's up to you to handle doing that, which is kind of the problem I'm in right now. Okay, so here we go. You can on, yes, you can. Okay, cool. How? So libdrm. Yeah, so you need to do it with Vulkan. Get string. Easy but limited. GL vendor. Yeah, so maybe this is possible. And I was just yapping. GL get string. Yeah, MTL device. Yeah, I have one of those. Let me try let me try what this gives me. I'm curious what this gives me, the OpenGL. I should be able to test this pretty quickly. Let's see. Because I'm curious how much information I can get. Because that would be really useful to just like have that information at the engine level if you ever want it. Let me just go to OpenGL at init. Okay, here we go. Here we go. So this is what it told me. I have an NVIDIA Corporation. I have an NVIDIA GeForce RTX. And I'm on version this. See, this doesn't give you any information about like the RAM. The scripture. I hate blend modes. They're so confusing. Source alpha 1 minus source alpha. Okay, yeah, let's see. Okay, so not portably in pure OpenGL. Okay, so if you have NVIDIA, you can get this from GL get integer. Let's try this. Oh, you need GL extension for this. Yeah, I don't have that easily set up right now. I don't use the extensions. Yeah, you can kind of see here that it's like yes, you can get this information, but it is a cluster to actually get it natively on each platform. Which is why I assume that the way, well, I don't know for sure, but I assume the way that like the big games do it is they just get this, you know, it's like you have an NVIDIA RTX 3080. This is easy to get. You can just get this from OpenGL. And then I assume they have a database where you can just look up RTX 3080 and it will have an entry that will be like, you know, my stats. Though I wonder, because then they would need, like, if you shipped a game like that, you would need to, obviously new graphics cards come out after the game releases, so maybe they don't do it like that. I don't know. Okay, what should I ask it? Yeah. Yeah, I have a GPU, so it makes my life easy. All right. I don't even know what to ask it. Buffer capacity. That's such a broad term. Well, you have to... It's an MTL buffer, I guess. I don't know. Like, what would I ask? Like, what should the size of an MTL buffer be for a typical game engine sprite batch? Because this is what I'm using it for. Typical 32 bytes. Yeah, see, like I already have, mine was 4096. It just depends, I guess. I don't know. Sprites per batch. You know, I'm gonna ask it the more interesting question. So, what happens if I try to write more into the sprite batch MTL buffer pool than the buffer pool can actually contain a single frame? Should the buffer grow, or I don't know, should writes be discarded? How do game engines handle this? Okay, here we go. This is exactly the kind of GPU resource management that I love. How GPT really likes to fluff you up. It's like, this is exactly the type of question that, you know. And then we get the little brain emoji. The core issue. Okay, so if you have a dynamic ring buffer for per frame transient data, usually versus each frame, you sub-allocate a region from the buffer and write to it. But if you try to write more bytes than the buffer can actually contain, then you will corrupt GPU memory or overwrite data. So yeah, we're avoiding this. This will result in validation errors. You must never write past your buffer capacity. You must handle overflow in your allocator. So how should you handle it gracefully? All right, here we go. They don't grow buffers dynamically in most cases. Buffers are used per frame batching. Are almost always fixed-sized ring buffers, because buffer growing means allocating new GPU memory, installing or rebinding everything. Pick a conservative upper bound, sub-allocate region per frame. If they overflow, they flush the current batch and start a new one, or defer rendering to the next frame. Okay, that's kind of interesting. Yeah, because I'm just like discarding anything that overrides. Flush the current batch and start a new one. Okay, that makes sense, maybe. Yeah. The thing is, like, Metal API doesn't expose the concept of a GL flush. Right? That's like a high-level OpenGL concept. So it doesn't really translate well to the lower level ones. The lower level APIs. So I don't know. Yeah, but like here, they're doing this. And like this is exactly what I have in my code here. Like I did this loop. Except, yeah, where I return, they flush. So yeah, that makes sense. I understand. Set buffer bytes, draw bytes. I guess the problem in that like it doesn't understand is that by flush here, I guess, yeah, they submit draw calls using this data. So I guess I would just have to handle this. Yeah, exactly. Okay, yeah, I understand what has to happen. I don't think I'm gonna fix this right now though, because it's kind of involved. It would involve, because like the flow of what I'm doing is like when I'm writing to the vertex buffer, I haven't even created a draw command yet, right? So the renderer doesn't even know that my intention for this buffer is to be a draw call. So like, there's no way for my renderer to like gracefully submit a draw call to free up buffers, because it's like, the renderer doesn't even know that that's what I'm using it for, because like the renderer doesn't know that it's a sprite batch. It just knows that it's a triple buffered resource, and I've exceeded the capacity of a triple buffer. So like I would need to return from the function like a failure case, and then my vertex buffer, my sprite batch, would have to understand that a failure to write means that we've reached capacity, and then we must submit the work up until capacity and then like busy wait until that work is done. And then the symptom of that would be a lag spike, because now you're like forcing a synchronization between the CPU and GPU, because the CPU is waiting for a buffer to free up. Or yeah, that works too, actually. Yeah, you might defer to the next frame. I guess my only fear with that is that like, if I'm drawing text on frame 0 that says something, and then that work has to be deferred to, frame 1, or I draw text on frame 1 and I have to defer it to frame 2. It's like, frame 2 from the game's perspective might not even be drawing text anymore. Like your game might be in a completely different state. So drawing text on frame 2 doesn't make sense either. It's like the CPU has to wait until it can actually draw stuff. So we really just have to submit draw calls and wait, I think, is like, yeah, it has to preserve draw order. Because like when I've submitted this call, or like this, like say I'm rasterizing text, and my vertex buffer is getting filled up with like font, like, letters, right? You expect all the text to make it on that frame. Okay. That's interesting. It's good talking this out, actually. This is tough. See, I never have to think about this, because in OpenGL, the driver underneath like handles this. Or like DirectX, it basically handles this. Or I guess I've never pushed OpenGL to actually know what it does in the case where it can't. You know what? I can just test this. What does it do? So if I make the sprite batch really small, what happens? Let's see. So if I make this like 8, and then I go to DirectX, what does it do? So it just works. How does it work? I don't understand how that works. So clearly it's able to handle this situation. Am I doing that right? Sprite batch 8. How does DirectX know that? So What are we doing? We bind, where do we bind the buffer? How do I get my filters back? I want to filter these. I have way too much stuff in here. How do you filter these? Filter. Current filter. Actions. Here we go. Well, the buffer's complete when it fills up. Okay, so here we go. Here's each of our eight quads. Should be 8 quads per draw call here. So in a single frame, what is it doing? Immediate context. So is it waiting here? So it maps the buffer for write discard. And then it draws. And I assume it just wait. It just like commits immediately. It has to. Yeah. Yeah, let me see. Let me try something. Because right now I've been committing at the... Yeah, so right now in Metal, I'm pushing the command queue. See, this is the difference probably, is I'm pushing at the end of the frame. So like command, commit. Where is it? Command, buffer. Where is it? Command queue, commit. Where is this? Commit, buffer. Here we go. Command, buffer, commit. Here we go. Found it, finally. Yeah, so I commit here after present, but what I should really be doing is committing, I guess, after the draw call's over. So let's go to frame begin, creates the command queue, a command buffer. So let's just say API I'm just gonna try this really quick and see what this does. This might actually break stuff, but we'll see what happens. So we commit one, and then we create a new one. Will this crash? Who knows? No. So now, if we set this really small, what happens? Where is it? So this should still flicker, I think. Yeah, so it still flickers because I'm returning. Now if I don't return, do I just get stuck in the busy wait cycle? Where is it? Command, I can't think. Return buffer equals. So let's just busy wait here until this is free, because I think this should work. Yeah, well, no, not quite. Yeah, you should do it. It's fun. It's actually a good exercise. You should just start. Don't wait till school. You just do it. Start small though. You want to start small and build up, because otherwise it's like super overwhelming. Okay. Okay, let's see. Yeah, you're right. Yeah, there's like two parts to this. Okay, let me think. Okay, so I need to make this function return something because I need to detect this failure. So write, basically, if we've looped around, I think we're getting close to the secret sauce. So vertex we'll just temporarily make these return things. This is just a proof of concept of can I escape this. So this should return, if this hits a busy wait, we just return false, meaning we failed to write because we can't. And then let me boolean and vertex buffer. So then where I call this thing through these few layers of indirection, unfortunately, is here. So this also has to return. And then the vertex buffer, the quad batch thing is down here. So it's like, yeah, so it's like I assume this write is going to succeed, so I execute the command. Yeah, I don't know. I'm gonna have to think about this because this is a problematic now too. Because like my other code assumes that write succeeds. Like this draw indexed call, I believe assumes that the well, let's just see what happens. So like, if not write end. So like if this fails, then we submit the batch and try again. Well, let's just copy all of this. So this should like force a draw. If it all worked out correctly. Oh no. I'm missing a semicolon somewhere. Right end, right here. Yeah, see, it doesn't like this. Okay, wait, it's because we didn't, what a mess. What do you mean I don't need to copy it? You certainly do. Because look, if we failed to write the current, you know, writing buffer, like we began a write, we've started submitting vertices to this buffer. And this is batch end, so we want to draw this thing here. So we're like ending the writes. Oh, here, you're saying that. Okay, I see. Well, it would reset the current pointer to 0 after the write. But yeah, you're right. I should put a return here just in case. Yeah, still doesn't do anything. I think this is just fundamentally not... Because what's happening here is like, if write end failed, then it just can't commit the work that we've buffered up for the write. Because we're not writing directly to GPU memory until we call this write end thing. That's when we actually map it over. Everything in here is just buffered on the CPU as like a little write buffer. Because it's slow to like write, you know, to the GPU buffer directly, because you have to like cross the PCIe bus if you're not on shared memory. So we defer that till the end of this. If this fails, the only time this would fail is if our writes this frame have exceeded the capacity of this buffer and its pool, which means that we must draw its contents, its current contents up until this failure point. And then after that draw has occurred, then the pool, the buffers that make up this vertex buffer pool should start to free up as the draws get worked on by the graphics card. Because of that commit, that command buffer commit at the end of this render command execute function, meaning this write end, which waits for a free buffer, should succeed. I guess we can test that, because clearly it's not. And then once that succeeds, we've now written more data into the buffer for like, you know, that we originally tried to write but failed. We should like succeed this time. And then we draw that. So it's like double thing. And this should probably be a loop, honestly, because like this would go until this no longer fails. So like maybe this should be like a while. Hey, how's it going? Oh no. Here we go. We are stuck in the loop already. Infinite. Did that really not break? What? Are we not returning our success case maybe? Did I miss that? Maybe this is never not failing. Let's go to... You would think the compiler would warn me. No, we're writing here. I don't know. Who knows? Sweet. Love to hear it. Yeah, compilers are fun. I enjoy them. All right, I think I'm going to undo the work here. I'm just going to... I'll look into this problem because I know it's clearly a solvable one because DirectX is doing it. The drivers do it for you. So I'll keep the warning, I guess. This is just going to have to be a to-do for now. The thing is, what DirectX is handling this without me even having to change my assumptions of my API. So clearly how I'm doing the buffer pool, it's taking just data. You know, you write to it, you push to it. You know, you give it a pointer to some data. You give it the size of the data, and it writes it to the temporary CPU buffer until you hit write end. And then So when you're done writing is when the scratch actually gets committed over to a real GPU memory buffer, right? Like it's on a CPU till we hit write end. And the way it determines so the managed buffer has a pool. So there's like not just one MTL buffer. It's like a pool of them, you know? So triple buffer, you have 3 of them. And we index which buffer from the pool through this buffer current thing, which is just an integer, which tells us like which buffer are we active in the pool right now. And when we write to the buffer, because we're copying it in one big block, because we don't want to map the memory until we need to, it tests like, okay, so like is our current position plus the size of the block of memory we're going to write to greater than the capacity, right? So if you're like in a ring buffer and you're towards the end and you're writing a block of memory that exceeds the capacity of like the remainder of the buffer, it basically enters a loop where it's going to seek to find the next available free non-in-flight buffer. It's just writing to a buffer. So yeah, it's annoying because there's like 3 layers of indirection here. You have like a vertex buffer, which implements a managed buffer, which is like DirectX doesn't have to do this. My DirectX backend, my vertex buffer write end, because it just maps, like it's just writing directly to mapped memory. Because the GPU drivers do a lot of work for you in DirectX 11. The DirectX 11 drivers do a lot of this for you. And Metal doesn't expose that sort of driver functionality, so you have to implement it yourself. The buffer isn't pushing draws. The buffer doesn't know about draw calls. It just knows that it's a block of GPU memory. That's the problem. The next function that reads this memory is the draw call dispatch, which happens independently at a different time. So like when you execute the command, you know, you have an API draw call here, which is like part of it. So this is where, like, if you actually want to draw the vertex buffer, because writing is different than drawing. Like I'm writing to it in GPU memory, but I'm not drawing it yet because those don't have to be at the same time. It becomes a command wherever you program it to become a command. So in this case, for the sprite batch, this is just here. This is like this stuff. Let me revert this to what it was. So this is the vertex buffer for the sprite batch that we're seeing. And batch end it's just a lot of layers of indirection because there's a lot that goes into this. Like there's a lot of conditions that break the batch, the sprite batch. Like if you change texture sheets, like if your sprites are on a different atlas, that's a batch break because you need to draw before you can switch. So there's like a lot of indirection here. But this is where it actually becomes a command that's executed. So like we create a render command, we execute the render command with this chunk of work, which is this draw vertex buffer indexed. Because it's implied that you would, as a programmer, give it a valid buffer. And it checks that, it validates this during the draw call. Yeah, I don't know, it's complicated. There's a lot of indirection here. But when you draw this thing, in my Metal backend, so this is the draw call. Like this is actually the draw call here. And the draw call can have a lot of stuff. It can have a vertex buffer, an instance buffer, an index buffer. So there's like more to a draw call than just the vertices. But the vertices specifically get bound here. So like we go from our vertex buffer resource, we extract its managed buffer, which is like the buffer pool that handles, you know, the buffer, the managed buffer pool is just a mechanism for managing GPU, CPU like synchronization of resources. So we're not writing to resources that are in flight for like a call that's already in the command queue. And it from the managed buffer, it gets the current buffer that's actually to be drawn. I have debug stuff printed here, which is what this is. And then it sets it on the encoder. And then, yeah, the encoder sets like the vertex buffer. And then it calls the draw calls, you know, actually calls like the draw index primitives, draw index. I guess all of these are the same call, draw primitives. It's just writing memory. It's just mapping memory for CPU write access and then ending the mapping. Because for performance, you want your CPU, you want the memory to be mapped on the CPU as briefly as possible, because the GPU doesn't like reading from mapped memory and the CPU doesn't like reading from mapped memory. So you should ideally keep the mapping window as tiny as possible, which is like only the time you're actually transferring data. So that's what write begin and write end, they basically just correspond to when you map and unmap. So the real problem is that write end can fail, and write end isn't responsible for drawing, but it's drawing that would allow the buffer pool to free up again. So like, I think the root of the problem is that it needs to be solved in this place, because this is where we're actually finishing the write and then submitting a draw call. This is like the point where these two guys converge. So, yeah, fun times, fun times. I love it. I say that sarcastically. Okay, I need to fix all this stuff because I put a lot of crap in here. I'm going to fix this later, though, because I'm determined now. So this is a void. And this is a void for now. I don't know how I wouldn't know that I have a valid vertex buffer. That's like implied by the architecture of like the code, is like if the buffer is ever invalid, it would have like errored a long time ago, because I check upon creation that the buffer is like valid. So if that fails, then the buffer, the program would just crash with a failure case. Okay, what is this map about? 839. Yeah, that's true. And that's why I said it fails gracefully. And that it fails, it doesn't, you know, it doesn't crash the program with a seg fault. It instead fails gracefully. What is happening here? GFX, oh, I'm back here. It's like, it's kind of like a similar question of like what happens when malloc fails. Like what if you reach CPU memory and you can no longer allocate? It's like At that point, you just have to gracefully fail, because if your dynamic memory allocation reaches the limit of your system, then there's no case in which you can recover from that gracefully, like in a stable way, you know? I mean, there is, but you have to really make your code complicated to do that. Yeah, but the problem is like, okay, so what happens if the temp buffer fills up? Then you need a secondary temp buffer, and then like a third temp buffer, and a fourth, and it's like, you're not solving the problem, you're just pushing it one layer out. At that point, I might as well just increase my buffer count, like my pool count. Right? Or am I not? I'm not understanding. Well, it's not getting clear because it's not drawn yet. Because right end doesn't draw, it just unmaps. So, yeah, it needs to be drawn. That's the fundamental problem, is it needs to be drawn. Or flushed, yeah. And like what I'm doing is essentially just like, well, I'm not flushing, I'm just not writing anymore. I'm just aborting the writes because it can't happen. It's a fun time. Okay, so am I really still getting errors here? API. Functions that differ in their return type. Man, I really messed this up. What functions, what headers in metal? All right, void. Yeah, I need to force a draw. That's true. It's like the only recoverable way, is you force a draw and then you wait. The CPU has to wait. It has to stall until it's like the frame has been drawn. Precisely. All right, well, I'm satisfied. Yeah, I could. That's what I tried to do here. I tried to do that. I just need to think about this some more. In theory, yes, I should be able to. And because the way that yeah, the thing is, it like from a architectural, like a code structure standpoint, is just I can't call it there, even though that's where it should be called in theory. Because like what you would maybe need to do is like, yeah, because you would call it here where this warning is being displayed, and then you wouldn't return, you would just busy wait, I guess, right? Because like this is basically a busy wait until like this loop condition breaks from this case here. And this frame equals 0 is basically just like the signal that this buffer is not being is no longer being used to render a specific frame number. Well, the reason you can't is because this is like an abstract API, right? So like, this is just a managed buffer. And like a managed buffer isn't a vertex buffer. This managed buffer resource is used by the vertex buffer, and it's also used by the instance buffer. It's used by the index buffer. It's used by uniform buffers. It's just a representation of a buffer that's safe to write to, in like an asynchronous, GPU asynchronous way. So like I can't just call a draw here because that would be like, that breaks the separation of concerns for what this thing is. What I could possibly do is like supply as an input parameter, there could be like a callback that's like if this thing fails to write, execute the callback. And then my vertex buffer callback would like implement, okay, draw it and then wait, you know, it'd be like a callback function. And that way this thing doesn't need to know what drawing is. It just has some escape plan for if this fails through a function call. Like if this was like if I took a parameter here, you know, like some auto like function call, like failure callback, and you just like called this thing, right? That's an option. Potentially. I think the real catch though is that I think I'm chasing maybe the wrong problem, because like we just demonstrated here, DirectX, which uses the same, you know, my same abstraction over how draw calls and buffer writes works, except I don't, in DirectX 11, I don't have to manage buffer pools because the driver does it for you. It exposes that functionality to you innately as a feature of the API of DirectX 11. So DirectX 11 is handling this case gracefully, and I'm still able to draw without having to do a function callback or force a draw. So I guess the question is, how is DirectX 11 internally handling buffer memory where it's not running into this pool limit? And I guess the answer could be that maybe it is dynamically allocating buffers under the hood and then like freeing them when necessary. Like that is an option, I guess. Like I could allocate buffers on demand and then just free it. Like, let me try something. Like if I did, this would be really gross. Like what I could do is rather than return, or not return, we break, but we need to like, we have a flag that's like force alloc equals true. I guess we could do that in the condition, but we'll just do it like this. We could potentially do something like this, where like if this fails, then we, I guess, necessarily have to make a new one of these. Or I guess you could do, I'm not even sure how I would structure this, to be honest. I would need like a temporary buffer or something. You have like an overflow buffer, a global overflow buffer or something. I don't even know. I actually don't know. You would have to like allocate some like fallback large buffer that just maybe lives persistently in GPU memory for cases like this. And then like free it. Okay, like you would sort of dynamically size that thing maybe. It's hard to know what DirectX 11 is doing though, because you can't really inspect at that level. Fortunately, they don't expose that to you. I think I'm just gonna leave it like this for now though, because I am mostly satisfied. Geez, I typed a lot. And realistically, the limit would never be hit. I should probably make this not green by default. Where's this color? There we go. So let me commit to these changes. You know, I'm going to ask ChatGPT. Dynamic buffers are not truly single GPU buffers. Yeah, I know this already. Runtime tells the driver, give me a fresh backing store for this buffer that the GPU isn't currently using. That means drivers often gives a hidden pool of hidden buffers. Each time you write, discard allocates. So it allocates another physical buffer. Must stall the CPU until at least one old version is free, meaning the GPU has finished using it. Interesting. All right, but I am going to end the stream here actually because it is getting late and I'm not going to go for 8 hours again today. Only 4 today. It's a new record. So I will stream again sometime later in the week. I'm not sure when. Sunday maybe. We'll see. But yeah, thanks everyone for watching. I appreciate the discussion. I appreciate Woot Dragon for helping me talk my way through this problem, even though we didn't end up fixing it.